Okay, so today in 7.6, we combine what we did yesterday with minimizing and maximizing the objective function with graphing inequalities, and this is what's called linear programming. Okay, so it's not programming in the sense of like, computer programming. You're not writing any code or anything like that. You're looking at a graph of linear inequalities, and you're looking at where those lines intersect, right? And then where those lines intersect, those are your points that you put into objective function, just like yesterday, to try to find min and max. Okay, so all these problems will have 3 steps. First step is to graph the inequalities, right? And so if you look at our below, it says objective function, and then it gives you 4 equations, right? So we got to graph 4 different lines. So yeah, so here we go. And then once we do that, then we'll plug in the values, and then we'll state what our min and max are. Okay, so I'm going to draw my graph. I draw it fairly big so it can kind of help us. Now, I have 4 different colors, so I'll try to do each line in a different color so you can kind of see where those lines are at. So for x equals 0, I'll do black, right? So x equals 0, where's x equals 0? That's this line right here. It's the y-axis. Okay, and then for in red, I'll do y is greater than or equal to 0. So where's y? That's this axis. It's the x-axis. Okay. So there we go. And then for these next 2, right, we got to get them into y equals, or, the form y equals mx plus b is how we normally graph, right? So if I was going to do that, I'd move 2x over, so I have y is less than or equal to negative 2x plus 3, right? And I'm going to do that in green. Boy, it's freaking out today. Okay, so remember, you start at 3. 1, 2, 3. 1, 2, 3. Okay, so I just kind of drew some lines. So starting at 3, go down 2 to the right 1, down 2 to the right 1, right? So there, and we'll connect. Okay, and then y, we have to do the third one. So we gotta move x over. So x is, or y is greater than or equal to negative x plus 2. All right. So plus 2, we'll do this in blue, right? So you start at 2, you go down 1 to the right 1, down 1 to the right 1, right? Okay, so our area is very, 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 very small, okay? So where's our 4 points? That's here, that's here, that's here, and here. So these 4 points, right? So this point will be easy to find. That's 0, 2. This point's easy to find. That's 1, 1, right? This point's easy. That's 0, 0. And then the green line, red line, the green line, we got to solve this for when x is 0. So let me do some math. Y is less than or equal to negative 2 times, oh, not 0. Take that back. Take that back. Not there. Okay? It's 0 is less than or equal to negative 2x plus 3, right? So subtract 3, so you get negative 3 is less than or equal to negative 2x divided by negative 2. So this point is x equals 3 halves. Okay. inequality sign, it does not matter here. X equals 0, and that's -3. Okay, so this point, this black point right here is 3/2 0, right? That's this point right there. Okay, so I've got 4 points. I got negative or 0, 2, 1, 1, 3/2 0, and 0, 0. Right? So now I got to, that was part A. Part B, right? And if you shaded all these, right, the center section right here would be right there. This little black area, maybe if I color it blue, maybe this blue area right here in between all those 4 points, right? That's your that's the shaded region, just like yesterday. Okay, so that's part A. So here's part A. Part B, find the values at each point. Okay, so I have my 4 points, right? And then I have my objective function, my z equals. So I'm just going to pick a point. So 0, 2. Right? At that point, remember, you plug those values in for your z and just solve, right? So 4 times 0 plus 2 times 2. Well, that's 0 plus 4, which equals 4. Right? And then at 1, 1. Right? So you have 4 times 1 plus 2 times 1. Well, that's 4 plus 2, which is 6. Okay? And then at 3/2 0. Right? Well, that's 4 times 3/2 plus 2 times 0. Well, 4/2 times 3/2 times 4 is 6 plus 0, which equals 6. Okay. And then at 0, 0, right, you get 4 times 0 plus 2 times 0, which equals 0 plus 0, which is 0. Okay, so that's part B. All right, and then part C. Okay, part C. Now you just say you have to find the min and max, so the minimum is 0 at 0, 0. Okay, and then this guy, make sure I did this right. 12, that's 6, 0, okay. Yep. All right, well, the max is 6 at both points 1, 1 and 3/2 0. Okay, so there you go. So it's very similar to what we did yesterday, just adding the graphing component in there. If you have any questions, please let me know. Yeah, it's not bad, but there's a lot of steps to it. So if you have any questions, just let me know. Thanks. But